Now you say, fine, isn't that great, you know, but how about 4 billion years? How about 4.5 billion years? That's the age of the planet. Why don't you show me when life began? Now that's a good question, and I've spent the last 45 or 50 years trying to find the answer. The problem is that the older the rock is, the greater the chance it no longer exists. What? Yeah, well, see, that's the way it works. See, on this planet, it rains, okay? There are mountains, and then it rains, and those mountains get eroded out. They just get washed out to sea, and then you get these sandy sediments, and it gets buried, and then you get a new mountain there, and these rocks get recycled over time. It turns out on Earth, the average lifetime, in quotes, lifetime of a rock unit is about 200 million years, okay? So we had lots of rocks at 4.5 billion years, but they get eroded away and eroded away and eroded away. And so now it turns out that the earliest history of Earth is not recorded on the Earth. Oh, we've got little mineral grains that have survived, but not the rocks that they originally were formed in. We've got mineral grains that are as old as 4.4 billion years, and some other mineral grains that are 4.2 billion years, but they're found now in much younger rocks. They've eroded from where they originally were formed and are redeposited. So you go back through time, there are only two places on Earth where you can get rocks, a whole lot of rocks anyway, between 3 and 3.5 billion years in age. One is here in Western Australia, northwestern Western Australia, called the Pilbara. And the other one is near the Kingdom of Swaziland in southeastern South Africa. And those are the only two little slivers that have survived to the present. There is yet one more older sliver of rock. It's 3.8 billion years in age and occurs on the southwestern tip of Greenland. But the problem with those rocks is that they have been pressure cooked. Oh, that's another problem with working on old rocks. See, the older the rock is, the greater the chance that it's been involved in some mountain building process. And if that happens, the rocks get crushed and they get heated up. They get pressure cooked, and that obliterates the evidence of life they might once have had. So we've got hints of life at 3.8 billion. Here in Western Australia, the rocks are well enough preserved that we can find individual microscopic fossils, and we find these stromatolites, and there are a lot of stromatolites, over tens of square kilometers. So they're a lot of fun to work on, and you get out in the bush and you collect them and you bring them back to the lab and you study them, and if you're lucky, you might find some microscopic fossils.